This meeting is being recorded.
Yeah. Sir, in the last video, we have seen time complexity. So how we can able to calculate time complexity for different algorithms we have seen very clearly in the last video. And one of the student posted one question. Sir, can you please explain the time complexity of the following cases? Sir, how many times it is going to execute? So generally, if it is starting from 1 to n, then n plus 1 time. But here, including 0, you are starting. Okay. If it is starting from 1 to n, we can count. But 0 means what? One more iteration you are going to get. So it will become n plus 2. So what about this case? Generally, every for loop will execute up to n plus 1 times. Okay. So when you have taken including the value of n, okay, for all these things, the base is nothing but this one, sir. For I is equal to 1, I less than or equal to n plus I less than or equal to n, I plus plus will run n plus 1 times. So just you have to adjust the values of these two things. That's all. Nothing. Okay. So here n plus 1 is the default value, but additionally 0th iteration is there. That's why I added 1. So it will become n plus 1. Sir, here n plus 1, if you start from 1 to n, both are inclusive. But here n is excluded. That means what? Minus 1. And here 0 is included. Generally, we have to start from 1. But we are starting from 0. Okay. That means a plus 1. One iteration extra. So what will be the value? N plus 1 iterations. Sir, what about this one? By default, every loop is going to take n plus 1. When if you start from I is equal to 1, I less than or equal to n. Okay. So this is nothing but n plus 1. So what about this case? By default, n plus 1. We are starting from n, but we are ignoring the value of n. That means one iteration loss. So minus 1, it will run n times. That's all simple. Nothing is there here. Clear, Akshay? Clear up to this? Everyone, please confirm. Clear up to this? Right. Second condition. See, clearly I'm explaining. Please listen carefully. So here, n plus 1 is the default execution time complexity for every for loop, which is in this format. I is equal to 1, I less than or equal to n, I plus plus. If any for loop is in this format, then n plus 1 is the time complexity. Okay. So here, if you take I is equal to 0, I less than n. Anyway, it is a for loop. That's why I have taken n plus 1, just for your remembering purpose. Second point, sir, when you are starting from 1, it is n plus 1. But we are starting from 0. That means one step before itself we are starting. That's why, sir, plus 1. Next, sir, including the n value of n means n plus 1. But here n value is not included. That's why minus 1. Okay, one step before it is starting, one step before it is ending. That's why minus 1 plus 1. It will become n plus 1. Okay, right. Sir, this is nothing but someone is asking, sir, what is n plus 1? No, first one is n plus 1. Why? N plus 1 is the default for every for loop. So if it is starting from 1, it is n plus 1. If it is starting from 0, one extra value we are getting. That's what n plus 2. Right. Sir, now in today's session, sir, I want to talk about matrix. Okay, matrix multiplication. Okay, matrix multiplication. For this, I need to calculate a time complexity. Okay, so I am not going in detail, just at a top level. Sir, what is the algorithm I am going to explain? Okay, what is the algorithm I am going to explain? So just a minute, sir. Give me 1 minute. Please wait. Right. So let us go for matrix multiplication. Sir, same time complexities for reverse for loop. Yes, reverse for loop is also same time complexity, because reverse means what? Number of iterations are fixed, right? Just you are going to change order, left to right, right to left. That doesn't matter. Okay. Sir, I am explaining matrix multiplication. Listen carefully. This is the code for matrix multiplication, sir. Okay. I is equal to 0, I less than n, I plus plus. Okay. So for j is equal to 1, sorry, j is equal to 0, j less than 3, sir, j less than n, j plus plus. And again, sir, here we have to take one more loop. K is equal to 0, k less than n, k plus plus. So here we have to calculate C of ij is equal to, so C of ij plus, so A of ik into B of kj. Sir, it is not like normal matrix multiplication. I mean matrix addition. It is somewhat different. Okay. So I will explain first of all this matrix multiplication. So with the help of some example, then you people will get some idea. Okay. Right. Yeah. So this is the for loop what we have, right? So now listen carefully. I'm going to explain this for loop, how it is going to functioning. So now just for our convenient purpose, I am replacing this with 3, or let me replace with 2. Let me replace with 2. Let me replace with 2. That means 2 by 2 matrix. Sir, the first matrix A is nothing but something like 1, 2, 3, 4. Like this I am taking. Sir, this is the first matrix. And my second matrix is nothing but 1, 0, 0, 1. Like this I have taken. Sir, what about locations? Sir, listen carefully. This will become 0, comma 0. This will become 0, comma 1. This will become 1, comma 0. This will become 1, comma 1. Like this I have. So this will become 0, comma 0. This will become 0, comma 1. This will become 1, comma 0. This will become 1, comma 1. Like this I am taking. Sir, now listen carefully. I want to multiply the two matrices. Sir, what will be the first time the value of I? I value is equal to 0 first time. Then j value. J value is also 0. Sir, next I am taking k is equal to 0. Yes, k value is equal to 0. Sir, now calculate C of ij. What is the formula for C of ij? Here I am calculating. So C of 0, comma 0 is equal to, sir, C of 0, comma 0 plus, okay, A of, so 0, comma k value is 0 into, so B of, sir, k value is 0, j value is nothing but 0. Like this I have. So what is the initial value of C of 0, 0? It is nothing but 0 plus A of 0, 0. A of 0, 0 will become 1. So 1 into, so B of 0, 0. It is also 1. Sir, 1 into 1 will become 1. 0 plus 1 will become 1. So C of 0, 0 value is nothing but what we have is nothing but this one. Okay, it is nothing but 1. Just now we calculated this. So this is the resultant matrix: 0, comma 0 element, 0, comma 1 element. So 1, comma 0 element, 1, comma 1 element. Like this we will get. Okay. Sir, this is the way. Next, since we are in the loop, next time this for loop is going to be executed, because it is the innermost loop, right? So it is going to execute one more time. Now, what is the value of k? Your k value got interchanged, but I value, j value are same. Only k value alone got interchanged. Rest of the things will become same, sir. Rest of the things will become same. Now what is happening here? Sir, now again I am calculating C of 0, 0 is equal to, sir, C of 0, 0. What is the previous C of 0? Just now we calculated 1 plus, so A of I value is 0, k value is 1 into, sir, B of k value is 1, j value is 0. Sir, that means 1 plus. So A of 0, 1. 0, 1 means what? 2. So 2 into. So B of 1, 0. 1, 0 means 0. Sir, 2 into 0 will become 0. So result will become 1. This will be again updated with 1. Sir, something like, do you remembered how you are going to multiply two matrices? First row is going to multiply with the first column. That's what we have done just now. Okay, so this is nothing but what is the first value in this particular matrix. Sir, please confirm if it is clear. Okay, rest of the things will become very easy for you. Clear up to this? Everyone, please respond. Clear up to this? That's what I told. Again, explaining this process will become difficult for me. Okay, that's why. So while listening, please concentrate, because it is not a normal simple 1 or 2 lines of code. Okay, so that's why. So take paper and pen when you are attending the class. Try to trace out along with me. Okay, I will explain next concept or next iteration also. Kindly look it once, Mohan. Okay, right. Sir, the next one. Sir, again k loop is going to execute one more time. Sir, your k value will become 2. 2 less than 2 is going to fail. Right. Then what is the next outermost loop? J value will be incremented. Till now, whatever we have taken is nothing but the first element. Now I will become 0. Sir, J value will be incremented by 1 unit. Again for J, this K loop is going to execute 2 times, right? Sir, what is the first time? K is equal to 0. Now calculate C of, sir, 0, 0, comma 1, right, is equal to, sir, initial value is 0 into A of I value is 0. Sir, K value is 0 into, so B of Kj, K value is 0, J value is 1. So result will become 0 plus, sir, A of 0, 0, which is nothing but 0. Sorry, which is nothing but 1. 1 into B of 1, 0. B of 1, 0. B of 1, 0 means what? B of 1, 0 or correct only, right? I value is 0, K value is 0. So B of Kj, K value is 0, J value is 1. Yes, A of 0, 0 means this element. So we have to multiply with 0, 1, this element, right? First row with the second column. Yes, correct only. So this value will become 0, right? 1 into 0. Sir, the total result will become 0. This value is 0. Okay. Sir, next. What is the next one? Sir, this K value will be updated by 1 unit or not? Now K will become 1. Sir, again C of 0, 1 only it is going to calculate. Sir, what will be the value? Previous value is 0 plus A of. Shiva Reddy, why you are asking these many questions, man? Why it is Java class? It is data structures class. Okay. Please ask relevant doubts in the class, please. Don't disturb when I'm taking a big program. So you can see, right, after completion of this, you can ask the query. Okay. Otherwise, please wait and see what is happening. So when I'm explaining the big code, don't disturb me, sir. Please, everyone. So next term, sir, 0 plus A of. So what is the next value? Sir, here the formula is nothing but A of Ik. I value is 0, K value is 1. So 0, 1 into, so B of Kj, K value is nothing but what? 1. So J value is nothing but what? 1. Like this we have. Sir, next 0 plus, what is the A of 0, 1? A of 0, 1 will become 2. Sir, 2 into B of 1, 1. B of 1, 1 will become 1. So 2 into 1, it will become 2. This value is updated to 2. That's all, final value. Sir, have you observed in previous case, first row, first column we multiplied. Now first row, second column we multiply to get this element. Okay. So this is nothing but what is the next iteration what we have for k is equal to 1. Okay. Sir, I think this one is very clear for you people. Please confirm. Do you have any doubts up to this? Clear? right? Now I am not going for rest of the things. I think you know the result will be 3 4. But what is the tree diagram for this I am drawing? So next time your I value will become 1. When I is equal to 1, j value will become 0. At the same time, j value will become 1. When j is equal to 0, your k value will become 0. Your k value will become 1. When j is equal to 0, your k value will become 0. Your k value will become 1. Like this, it is going to execute in a tree fashion. Sir, since it is a 2 by 2 matrix, we have two entries. If it is a 3 by 3 matrix, then so I value will be 0, j value will be 1. So I value will be 0, I value will be 1, I value will be 2. For this, again, you are going to get a 0, 1, 2. Again, for this, you are going to get a 0, 1, 2. So again, for this, you are going to get a 0, 1, 2, like this. For this, again, so 0, 1, 2. Okay. For this, again, 0, 1, 2. For this, again, 0, 1, 2. For this also 0, 1, 2, 0, 1, 2. So k values I am drawing. Like this we will have, sir. Okay. So if you want to get one element, sir, how many iterations you have to make? So first row into first column, three elements will be there. These three elements will be multiplied with these elements. This is nothing but how practically, okay, how practically this matrix multiplication program is working. Okay, sir, now we will analyze time complexity for this algorithm. If everything is clear for you people, like how it is working internally, if it is clear for you people, then I will go with sir, time complexity calculation of this algorithm. Please confirm, is it clear for you people? Clear? Yeah, no problem, Shiva. Because you have joined in the middle, so you don't know what is happening here. Okay, just you need to wait, then you can ask your doubts. No, 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 sir, only three for loops, because it is a three for loops, not four for loops. For any matrix, three for loops only. Because, sir, how many subscripts we are taking? Three subscripts. Sorry, two subscripts. Okay. So for matrix multiplication, you have to write only three for loops, irrespective of order. That order will be depends on the number of iterations. That's all. Okay. Right. Now we will calculate, sir, complexity for this. We will calculate a complexity for this. As we know that this statement is going to execute how many times? General for loop n plus 1, right? N plus 1. But sir, if it is starting from 1 to, okay, 1 to including the value of n, then we have taken n plus 1. But we are starting from 0 plus 1. We are ending with one value before, so it will become n plus 1. Okay, final value is nothing but n plus 1. Okay, right. Then what about this value? What about this line? What about this line? Sir, it is also going to execute same n plus 1 plus 1 minus 1. But how many times outer for loop is executing? Those many times inner for loop will execute. Only for true, not for false. So it will become n into n plus 1. I can take like this. So which will become, sir, n square plus n, right? That's all. Sir, next I am taking this line. Okay, I am taking this line. So if you want, better to consider this one also, otherwise you can ignore. Okay. Okay, better consider. Sir, how many times this loop is going to execute? N square times. Because, so how many times this loop is executing? Those many times this loop will execute this statement. Like how many times? N square plus n minus 1, I think so. Otherwise, I can take this instruction as it is. This instruction as it is. But here one value you can able to subtract. So n into n, which will become n square. Okay, which will become n square, because so how many times this loop is going to execute? N into, sir, n plus 1 times. So n times because of this, but this condition true means then only it will execute, right? That's why n into n. Okay, n square is the answer. Sir, how many times this loop is going to execute? Already this one is going to execute n square times. So n square into again n plus 1. Sir, minus 1 plus 1. Okay, that means how many times it is going to execute? Same like, so n square into sir n plus 1 times. Okay, sir, this is nothing but what we have. Sir, what about this one? What about this one? Sir, same like this one only, right? But what advantage we are going to get? So just one value is going to be reduced. Okay, so that means what? Sir, n square into n square into n, which will become n cube, right? So this is nothing but what we have. Sir, the total time complexity of sir matrix multiplication will become n plus 1 for first loop plus n square plus 1 plus n square plus n for second for loop. Okay, n square for third for loop. Okay, I mean that statement. Then sir n square into n means n cube plus n square, n cube plus n square. Sir, for fourth, that is the fourth line, that is nothing but a k loop. And the last loop, it is going to execute n cube, n power 3. So if you substitute the values, so how many n cubes are there? I think 2 n cubes. Sir, 2 n cube plus how many squares are there? Sir, this is 1 n square, this is 1 n square, this is 1 n square. So 3 n square plus how many n's are there? This is 1 n, this is another n, 2. Okay, that's all. Plus 2 n plus how many constant values are there? I think only 1. Okay, like this. Sir, now it will become, that's all, simplified instruction. Sir, in general, we are going to take like sir, big O of n cube. Why I am taking big O of n cube? Because highest power, highest what you can say, highest power is nothing but we have 3. Okay, this is nothing but what is the time complexity for matrix multiplication. In the last video we have seen very clearly about addition, all those things, like I explained very clearly with different approaches. Sir, please confirm, so is this matrix multiplication time complexity, is it clear for you people? Yes, thank you, Pradeep. Right. So I think with this, you know very clearly how you can able to calculate sir space and time complexity of any algorithm, right? So now you are in a position to prepare these two entities for any program. Just what we need to do, we have to analyze what are the different steps are there, what are the different instructions are there. Okay, so with this time and space complexity, theoretical calculations got completed. Okay, sir, now we are going to talk about okay, sir, algorithm 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 cases, that is sir, we have best case algorithms are there. Sir, we have so average case algorithms are there. Okay, and so worst case algorithms are there. Okay, next sir, asymptotic notations are there. Asymptotic notations means what? Sir, how you are going to represent? Okay, asymptotic notations we have. So to represent these time complexities directly, we can't use that n square like that, we can't give, because everyone calculations are going to be changed. So that's why we have some 5 notations are there. Okay, that part we will discuss in our next class, sir. Okay, yeah. Can we do one example with a recursive program for time complexity? Yeah, we will see, Vishal, because in the recursion, we are going to talk in detail. There I will cover. Okay. 1628 line. Just it is just ignore Arjun. This one is not required. Okay, just ignore. So highest order, whatever you are getting, that will be the complexity. So in our previous classes also, sir, when we are calculating what is the highest order, we got n square. That's why big O of n square. So in our previous algorithms also, sir, whenever you are calculating that higher order, whatever you are getting, that is nothing but the complexity. Okay. Right. So this is nothing but today's session, what we have.